Hello, everyone. Okay, can you hear me? So, hello, everyone. As Max said, I'm Felipe. I'm happy to be here representing our Get Your Guide OS team and share a little about the learnings we got through our modularization process. And then to kick things off, let's start with why modularize. So, it might not be for everyone, for every code base. It might depend on the process of scaling you are or your company is. Uh, for us, it has been very good because, to name a few benefits, it allows multiple engineers to work in parallel with little to no impact in each other. So you can scale the team, grow the team, and work in parallel. It also helps us to build products that are flexible and that we can change fast. So, for example, we want to compose small units into fully working apps. For example, app clips is a very good example. You want to reuse functionality from your main app into an app clip. And then also app clips are challenging because it must have up to 10 megabytes of uncompressed size. So a modular setup is something that help you in that sense. And then also with that, you have like a good practice in terms of code. It is you have like reusable, concise modules that doesn't leak much. You don't mix the domains. You have testable, reusable code that is also easy to adapt. And then before we dive in, to give you some context about our project, currently the size is at around 100,000 lines of code, 98% of which is Swift, and then only 1.54% is Objective-C. This wasn't the case in the past. In the past, we had much more Objective-C, especially before also we moved to use Swift Package Manager. So you know a bit of the size of our project. Let's now give you some context about how our modularization process went and how our team scaled since everything started. So back in 2019, before the team even started to scale, our code base looked like this. It was mainly a main app, which would call a monolith. So the single Xcode, a single Xcode project, all code there. The orange Get Your Guide icon represents the main app target, and we had all the code inside it. And then that, of course, as part of an Xcode workspace, and third parties manage it through Cocoa Pods. So that was then everything in the same repository, a monorepo, which our project is still like that until nowadays. And then in 2019, the team started to scale, right? And then as the team scaled, we started then to extract code into new modules. So there were new Xcode projects with dynamic frameworks. So those with the yellow toolbox icon that you are familiar with, right? At that time, then we had we had more engineers working parallel, and then we had some struggles with merge conflicts, as you may be familiar with as well. Merge conflicts, and then it was also pretty hard to keep the project settings in sync across the whole workspace. Because of those issues, in the summer of last year, we migrated to use Twist. So for those who doesn't know the tool, with Twist, you can basically automate the whole generation and management of your Xcode workspace and Xcode projects. So basically have a Swift source code, and you define your modules, you define everything, you can reuse some code, and then you generate your project again and again. So you don't have to version all the PBX proj files, the Xcode project and workspace files, and then you don't lead, conflicts doesn't happen. So it helped us then to avoid conflicts. Oh yeah, there is Twist. Yeah, so Twist was managing our whole workspace, whole projects, everything. And then we didn't have any more those merge conflicts. We could reuse Swift code to ensure the project settings were optimal in both debug and release configuration across the board, and made our life pretty much more easier in terms of managing our whole dependency graph. It's important to say that at this point last year, our team doubled in size, so we had then 12 iOS engineers, right? So before we dive in, just wanted to say that the learnings we're going to share today, they might not fit you. You might have a team that is the double of the size, the third of the size, but nevertheless, we hope some learnings might be useful for you. All right, so before we dive into learnings and show you the setup we went with, we want to share we of course want to give you the problems we are facing with that setup, or the most important problems. So mainly App Launch. the app launch was taking a very big hit. So as I said, dynamic frameworks, we were adding more and more modules. We were breaking down our app. And this was then increasing and spiking the app launch. And then we suspected, highly suspected, it was due to many dynamic frameworks, which kind of known to increase the app launch. And it's important to say all our own modules, internal modules, all third parties, everything was dynamically linked or most part of the dependency graph. So this was kind of very heavy for the app launch. What happened then? We stopped adding new modules. At that time, we had around 25 of our own modules. And then the team was still scaling. We had new engineers, new product teams, and then we were basically adding code to the same modules. We were mixing up domains, and this wasn't good. So we had to find a solution. Aside from that, since we knew it was mostly because of dynamic linking, we really tried moving to static linking. And then it wasn't just an easy switch. We tried that, but here are some of the problems we faced on that setup. So duplicate symbols. If you already tried static libraries, you're gonna know that it's easy to hit those sort of issues, especially in a pure Xcode project-based setup. Also, something that is pretty challenging is the complexity of managing resources. So generally, then you have a different the resources are in a different target, and you have to manage your source code in one target, your resources in another, and it's hard to deal with those. So basically, basically that call that you are used to do, like bundle for this private reference to access your bundle, doesn't work because the code is not there, is in a different bundle, and that's tricky to handle. One thing we could also do, and we try to do a bit, you can mix up dynamic and static linking, but that also may get very tricky depending on your dependency graph. So it's kind of hard to know what to use in what place of your dependency graph. So like, should a base module be dynamically linked? Should a feature module be statically linked? So it is also kind of challenging to decide that in a complex dependency graph. So you may also face duplicate symbols in compile time and also in runtime. Apart from that, we also had in that whole situation opportunity to improve other areas. So for example, we want to say goodbye to Cocoa Pods. We want to try a more modern tooling, more modern dependency manager. So with those issues in mind, we had an initiative beginning of this year in our platform team. And then let's look at how we did it. So first thing, we defined the goals. We had three main performance metrics that we wanted to be stable as the app continuously scaled. And we also wanted them to be continuously monitored, right? So we could be sure they were really, really stable. So as you could guess, app launch, build times or your whole build process, because it can heavily be impacted by the linking you use, by the modularization you do. So both clean and incremental builds. And also binary size. So if you change your modular setup, binary size is also very likely to be affected. So it's something we really wanted to ensure was stable. And then again, it was opportunity to improve the developer experience or to keep it as good as possible. And also, if we could move to modern tooling, that would also be a plus. I won't dive much into how we did our whole migration, but it's important to say we did run an exploratory phase. There we extensively compared different dependency managers. We compared static and dynamic linkage, twist, as I said, SPM, both together in separate. And then we mixed up everything and compared the results. So I'm not going to show those exploratory setups, but more navigate you through the learnings we got from those. So first main metric we wanted to ensure was good and stable, app launch. So then linking and app launch. Let's first say what is linking. So linking is what, in a simplified manner, basically does the job of linking all your frameworks, libraries, your objects, and combining them into a final executable binary in a final executable app. And like I said, we really wanted to try static linking. And that's mostly because with dynamic linking, most part the heavy job is done during app launch. So you can also do like some manual DUL deopen and manually lazily load the dynamic framework, but that's tricky. Generally, they are by default loaded when the app launches. And during compilation, just some pointers, just some promises of the symbols are linked by the compiler. So most work is done during launch. While true static, they're fully linked during compilation time. So you save work during the launch, you save work during when your users are actually experiencing your product. And then during our investigations, we heavily relied on the Xcode instruments, especially the app launch template. So in that template, you can see all the phases of your app launch from pre-main, post-main. So, and then through it, we could see that the biggest chunk in our app launch was indeed loading the frameworks pre-main. So this kind of confirmed our assumptions. And then we also, in the setups we had static linking, we were able to see it really going down a lot. So really recommend that if you're playing with linking, with different types of linking. This also O2 command is pretty good. So you can run in your command line O2 -L against your app binary. So we had some setups ready. We compiled and generated the built binaries. Then we would run this command against the binary, and it basically dumps everything that is dynamically linked to your app. So we could confirm what was really dynamically linked and what was not. For example, in our case, we had a setup that we thought everything was static, but it wasn't true. We still saw two precompiled XC frameworks that were dynamically linked in the middle of everything. And we also saw all the standard libraries being also dynamically linked. So that's pretty good to use. And then for observability, we relied on Metric Kit. So you have live user data from iOS 15, you collect the data. In our case, we sent to Datadog, we set up observability, and this has been ensuring and giving us observability that metric is fully stable. All right, so let's go to the second main metric, so build and compilation. So as I said, we explored different setups, and in our case was a bit unexpected, but even on static linking, the build times were almost the same as when we were doing dynamic linking. As I said, this could be because of our setup, because of our dependency graph, so it's very important to try out in your own project. But it's what it happened for us. And then again, even if dynamically linked, even if we're static linking, everything is linked during compilation time, which tends to be slower. For us, it was almost the same. And then I just wanted to say that some folks in the community, they even go with a setup that you have dynamic, fully dynamic in debug and static for release builds. So you have a faster compilation for your developers and you have a faster experience for your users. For us, again, the difference was very small, so it is not worth the effort. And since we went with SPM, SPM doesn't allow you to control the link of all the targets you have declared. So you don't control that, you have to go with static by default. But maybe in the future, we're gonna be able to try that out. And then observability, we use it heavily Xlog parser. I really, really recommend that. You get a full detailed report about the parallelization of your build. So here you can actually see an example. You have the total time to build, the amount of targets, and you can actually see a timeline of your build. So if it is more serial than parallel, and you can then optimize over that. In our case, we have a full report like that being periodically generated. And we also collect the total compilation time in CI, and we monitor that. Apart from that, when we talk about compilation, another concept we investigated is interface modules. So I brought this simple example. This is a build tree that doesn't use interface modules. So you have at the top networking, which is a base module. And then you have analytics that depends on networking. So they compile in sequence. It's a serial compilation. Analytics has to wait for networking to be ready, so it can compile. And then you have two feature modules, login and checkout. They don't depend on each other, so they can compile in parallel, but they only start to compile when both networking and analytics finish it compiling, right? So if you were to use interface modules, this is how your dependency build tree, your build tree could look like. So you see like the parallelization is way better, and then the total build time would also be improved. And this, by the way, would be like in a clean build. So for example, in the right hand with interfaces, networking analytics, they're just interfaces of what you expect from your networking and your analytics modules. So they're very simple modules. They only contain a public API with what you expect from the functionality, right? Only the abstractions. And they both then don't depend on each other as they did before. They compile in parallel. They're very quick to compile. And then after they finish it compiling, you have then the feature modules compiling in parallel because they only depend on those abstractions. And you also have analytics live, networking live, the concrete implementations also compiling in parallel. So this tends to be super good. And then it's important to say that then the analytics live and networking live, they are then injected into checkout and logging in another place without them even knowing in your central dependency system, for example. So just to formalize then some of the benefits and the learnings we got, with interface modules, you can have a faster compilation, mostly because you are increasing the build parallelization and you are better using the machine cores. You're gonna have like a flattened dependency tree. So basically your dependency graph, your dependency graph is gonna be more wide, meaning your dependencies, they don't carry too many dependencies being direct or indirect. So that tends to be very good in that sense. And also we tend to apply a lot, one of the solid principles, dependency inversion, we tend to apply a lot using protocols in our Swift code. But doing that, you're applying the same principle in a framework level. So to give you an example, let's say you have a checkout functionality and you need a payment services module. So you're going to depend on the payment services interface. In your main app, you might then inject a payment module that has all the payment methods there built in available. And in your app clip, since you want to have a simplified experience and a faster and a smaller binary size, for example, you can inject another concrete payment services that only has Apple Pay. So this sort of flexibility tends to be very good if you're scaling your app and if you want to, yeah, deliver very good experience to your users. So the last of our metrics, the binary size, it was also smaller for us with static linking. Again, even though it tends to come with worries that if you use static linking, it's going to duplicate your symbols and it's going to increase your binary size. It might depend on each case on the dependency graph, but for us, it was smaller, around 50%, 15% smaller. And we were then going deep and trying to understand what was the reason, and it was mainly because with static linking, you have full support of that code stripping, which means if there's code you don't use in your app that gets that code stripped, that doesn't get shipped with your binary. This is especially important if you use third-party dependencies that we tend to underuse. So let's say you use a tiny subset of the functionality of your third party, you might benefit a lot from this. So you're going to have a lot of code that's stripped, and you're going to have a smaller binary size. And again, with dynamic linking, it doesn't fully support that. And that's mostly because during compilation, the compiler only links promises, pointers. It doesn't know fully what it can and what it cannot remove from that package, that module. So yeah, in terms of observability, it's very simple for binary size. We only archive the app. We archive for a specific device module. We collect the IPA size. It matches the App Store Connect size. We monitor that and we ensure it's stable while we grow. All right, so finally the Swift Package Manager. So as mentioned before, we also evaluated different tooling, different dependency managers, and here's a summary on why we chose to stick with SPM. And before that, let's look at how our setup changed. So the setup is almost the same. We still have an Xcode workspace. In this case, we don't have Twist automating the workspace anymore. This is mostly due a limitation with Twist managing a local package.swift. That's not a big deal for us because the only thing we have to manually manage it is mostly shared workspace level schemes. We might have conflict on those, but those conflicts, they're very simple to solve. They're simple to reason about. Then we have a single Xcode project. This one, thankfully, automates, fully managed and automated via Twist. So in this single Xcode project, we have all our apps. We have our main GetYourGuide app. We have app extensions. We have preview apps where we run a subset of like a piece of the app, a specific functionality. And we also have the second icon there, UI tests. And that's mostly because SPM doesn't support host apps. So this is a trade-off if you move to SPM, which in another hand, you have your tests inside SPM. You don't have a host app. So you also have your tests tends to be more deterministic because you don't have a running app that might have side effects on your tests. And then what really changed, we have a package.swift. In this package.swift, we have all our internal modules declared. We have test targets, production targets, we have test support targets. And when I say everything, it's really everything. We have internal modules and third parties, everything within this package.swift. So we control our whole dependency graph in a single place. And yes, we are using static linking, which is the default from SPM. And when we provide packages from the package.swift to the Xcode project based apps, we leave them automatic. And then by default, they're also static linking. So we have a setup that is fully in with that type of linking. All right, let's look then in Zoom how our setup looks. As I said, the core of the new setup is a single package.swift. I won't lie that is very big, is huge, but then at least we have the whole team managing the same, all our dependency graph, our modules in the same place. Sometimes we have also issues with packages that don't load, especially when we update third parties, but that happens very occasionally and doesn't block our team too much. But that's definitely a minor downside. The packages include resources, so we have fully featured modules with assets, core data models, everything, localized strings and all. We then really move it to use to break down our modules into live and interface modules. I want to bring you a quick example here. So we view that again. So in the bottom, privacy is the interface module. It's just a declaration. It doesn't bring any dependency. It doesn't bring anything. In the top, we have privacy live, which is the concrete implementation. So it links to privacy. Then it's gonna conform to the privacy public API to the interface. It then uses a lot of other internal dependencies to do its job. It uses third parties, has resources. It's a fully working module. But then again, this only get linked to our central system. Throughout our package.swift, we mostly use privacy, which is very lightweight to depend. And then about what we want with this setup ultimately, or where we target, where we want to go in terms of balance between Xcode and SPM. We want to have Xcode with pretty dumb apps. We want to have only main.swift, app delegate, and we want to link to Swift packages and have all the work done there. So ideally, we want to move also the dependency injection system, the routing system, everything. That's where we aim to go. And I wanted to bring a lot of trade-offs, but time is little. So here are the main ones we found out. So as I said, we wanted to go to static linking. That's something that SPM optimizes a lot. We have that by default in the targets declaration. And then our whole dependency graph, internal third parties. And not only that, but SPM does an amazing job of deduplicating symbols. So those issues we had in a pure Xcode based approach, we don't face them then anymore, as long as we are touching code that is within SPM. Apart from that, as I said, now we manage it, our dependency graph within SPM. So before we had to close Xcode, open our Twist workspace, change the declaration of the modules, regenerate the project, and then it could fail. It could fail during generation time. Now we only do everything within Xcode. We have the compiler supporting us, and that has been a game changer in how our team manages our modules. And then I also mentioned the issues with sources and resources being separate. Within SPM, you just declare a target, it has resources, you don't have to worry about that. Most likely, SPM creates a static framework or something under the hood, and then it bundles everything together. So not everything, not always is flower, not everything is flowers, not everything is perfect. So let's talk about the issues, the downsides, or the main ones. If you try to mix Xcode and SPM, you might face a lot of issues. For example, we had a very big curveball in the end of our migration. We had then the issue is that we were facing duplicate symbols. We had a code in the main app target in the Xcode project. It had tests, and it was using the package provided from our package.swift. And we basically had the production target, the test target using the same statically linked libraries, and they were duplicating. It basically wouldn't compile. The workaround for us is that we moved that to within SPM, and with SPM that doesn't happen. So the learning here is if you want to move to a setup that is like that, try to move as much as possible to SPM, otherwise you might face this sort of problems. Yes, and then with Twist, when we had Twist fully automating our workspace, we had a tool, the support of a tool called Twist Graph. So Twist Graph, you're running the command line, you see your whole dependency graph. As I said, we lost Twist support in the workspace level, we lost full support of the tool. But in the bright side, we built a tool of our own. So it's a tool that works based on a package.swift, and it does the same job. It's still private. We might even open source one day. It has been working pretty well for us. And the last one I wanted to bring, if I have an Xcode project, you have full control over the build settings. That's something that SPM got more mature, but still you can do everything you can within Xcode. So for example, if you have watched the latest WWDC link fast talk, you have new linker flags you can pass to the linker. You can speed up static linking. We can't do that yet, so unfortunately, SPM doesn't fully support linker flags. They don't fully work. All right, now let's look at some results after we migrated. These are the impact, these are the results we had in our app after applying this setup. So for the app launch, by just tweaking the setup, we had from 30 to 6% improvement on the app launch times. So again, we touched a very specific pre-main phase of the app launch, and still the whole app launch process improved by that. It depends on code and hot starts, OS, device model, and everything. Binary size got smaller, so 7% smaller in the download size, almost 20% smaller in the size it takes in the user device. And also the build times, even with the worries of static linking and compilation, 10% faster, especially in CI, it got even faster. So for us, also an improvement. And in terms of how everything evolved, I mentioned before we had 25 modules. So with the new setup, we unblocked the team. Now we have almost around 70 of our internal modules. So we almost tripled the amount of modules in 3 months. And from the 70, 20%, they're broken down into interface and live modules. That's mainly it. So a quick recap. If you are scaling, if you want to have a fast app launch, static linking is your friend. Of course, try it out. It might not be for every app, for every dependency graph, but it really might benefit you. And SPM is mature enough. It has issues as any software, but it can help you achieve a modular setup. So this is something important to say. And again, with interface modules, we got tons of benefits from faster compilation, also dependency inversion, more flexible code and product. So that's something I really recommend as well. That's mainly it. You can find references from things I mentioned here in the talk if you want to check them out. Some talks from WWDC that helped us. And that's it. Yeah, you can try our app in the test flight beta as well. Thank you very much. I'm very curious to hear what is your experience with modularization and scalability. I hope you grasped some learnings, and that's it. Thank you.
Test, 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 test. Okay, we've got this little cube. I'll come over here. I can throw this at people who want to ask questions. So anyone have any questions to Felipe? Raise your hand. Oh, that's quite far. I'll start with you.
Hey, so do you still have some Cocoa Pods?
Sorry, you asked if we still have Cocoa Pods?
Yes, do you still use it?
Yeah, that's a good question. So we still have, but only because we have two tooling related or automation related packages or frameworks, dependencies that they are not fully provided via SPM yet, but they're always like stable, they are binaries, and yeah, but we fully plan to move that to SPM in the future and kill that. At least they don't get shipped with the app. They only use it for like debug automations and things like that. Thank you.
Maybe to add to that, oh, that's very buzzy. We only have, I think, Swift lint and
Sorcery.
sorcery. So it's just like code generation and stuff that's not an actual binary target. So who was first? The very back. Oh, I'm going to break some laptops if I do that. I'm sorry.
Yeah, nice tool. Thanks for the presentation. I saw in your reference in the end, you mentioned another linker, kind of more advanced linker, ZLD. Did you try it, and what is your experience?
Yeah, so to be honest, we didn't try that. And we, for us, it was like we really wanted to change everything and already go to static. Then we just did that sort of different explorations, but that's something we definitely didn't try. But it's something we know other companies use. It tends to speed up your linking, but it's kind of one way or another really wanted to move to static linking because I guess even with a faster linker, you still, if you have a dynamic linking, it's still going to be on app launch, right? So I guess we really wanted to cut all of that off as much as possible. But if you try that out and have some learnings, we'll be very keen to hear as well.
Yeah, I just tried it. It's not for production, of course, because not battle-proof tool, but it may save some time during development. And yeah, it's open source and it's easy to use, integrate.
Nice, pretty cool. I guess we can talk more later. Thank you.
Cool.
Hello. Yeah, thanks for the talk. And my question about derived data. So, of course, we are good engineers and shouldn't follow magic tricks, but still dropping derived data is still the way to solve some issues. And as I remember, for SPM, it means that all your third-party libraries, all your check-outed sources will be dropped. And on the next line, Xcode will try to check out them. So do you suffer from the same thing? And maybe you have some trick for this?
Sorry, I didn't fully understand. You mean like the during launch and the optimizations of derived data?
So if you have something wrong in project, maybe after not so good changing of the branches, you feel that's something with the build process, it drops some strange errors. And still for developers, it's the way to solve it, just drop driver data. And usually nobody tries to understand what's really inside this driver data. Just drop the whole folder, and Xcode holds these checkouted sources for third-party SPMs. It means that when you start your project again, I mean, open the Xcode with the project, starting to check out it, and it could take time. So do you suffer from it, and maybe some tricks for it?
Yes. If I got it right, like especially we suffered when we were changing third parties, for example, and then sometimes we had to just nuke Xcode completely, and then Swift package SPM would then download clone all the repositories. Sometimes it do fails indeed, but again, we are not generally touching much the third parties. We try to limit them as much as possible and move away from them as much as possible. So it's not something that has been pretty impacting for us, but definitely have faced some of those issues. and really hope that SPM is going to get even better in that sense in the future.
And one more thing, yeah, as you mentioned, migration from Cocoa pods to SPM. For us, one of the difference was that in SPM there's no flag to choose your architecture. So which architecture do you want to build for? And for us with mixed devices, some have new chips, some still have Intel chips. And without this flag, it was difficult to build the process, right build process. Do you have the same thing?
Yeah, we didn't face those. We were mostly facing with Cocoa pods, and before some third parties were fully supporting ARM 6.4, for example, right? When it really came out. Since we moved to SPM, we didn't have any problems. And as far as I know, it by default it uses the active architecture, right? So and then it fully works. We never had problems both on simulator and actually it's very important to say as well, we are using M1 Pros here. So we're also building our own machines, our simulators, everything, and we only mainly use ARM 6.4 based architecture. So and with that we don't have problems.
And so third thing, that's and the last one. You mentioned so this modularization, and not sure you mentioned some approach how to achieve these separate models without the whole app. Do you have something so the team could not run the whole app, not build the whole app, but have something smaller, run their features, achieve their feature a bit faster, and so on? You mentioned something, but could be interesting. What exactly do you have for this?
Okay, I guess you mean like the part about the interface modules, or no?
Yeah, I think yes. Mostly it should be for interface modules, at least.
Yeah. So yeah, with interface modules, if I got it right, then we extensively use it. And then, for example, let's say you have a checkout feature, then you depend only on an interface. Every time you have an app that uses checkout, it's a feature module, but you don't have like a fully executable app, right? In that module, it's just a package. Then you're gonna have an app that then uses that package, uses that functionality and runs. In that realm, then we have our dependency injection system, and it's where we then only the dependency injection system, only that target knows about who concrete implements what the checkout needs. So in that sense, there that app target links to the live, to the concrete module, links to the uses checkout, for example, injects the live into it, and checkout doesn't even know what's concretely implementing the functionality it needs. So that's something we do in the main app target, we do in preview apps, and also we might even do it in the app clip we are currently building.
Probably it's exactly about these preview apps. So
okay,
so you have some.
All right, so yeah, the preview apps are just like, for example, we have checkout, and we used to use a lot in the past because our compilation times were not that fast. And then let's say the fintech team engineers here, they wanted to test their feature in isolation. Then they would run the checkout mini app, preview app, and they would just kind of, play with their own functionality. To be honest, like we have not using that fully or that much nowadays because our build times are so fast with the M1 Pros and with the optimizations we did that generally we just build the whole thing. And but that's the purpose of those apps. Thank you.
Yeah, thanks.
Hello. So launch speed or something like speed metrics on your app. It's honestly good, but do you have any another improvements? For example, I don't know, the stability, improve your navigation system or something. I don't know. What else?
Sorry, I couldn't completely hear you.
So you have some metrics. You mentioned some decreasing some launch time, for example, yes, or build time, or okay, it's so. But do you have some other metrics, for example, improving the stability, navigations, or some cases like show, just for example, show model window or full screen model or something like this? How it depends on your improvements, for example?
Okay, yeah, thank you. So like this initiative, like we're mainly focusing on those three metrics because we knew or assumed and evaluated it would be the most impacted ones. But as a whole iOS team, we do monitor a lot of the things we have. So we try to, like for example, we try to make the screens as responsive as possible and not have hang times. And we're building up. We're trying to monitor more and more performance metrics. But in terms of the modularization, I wouldn't say it improved much of those. It mainly focused on this. But our team has been done an amazing work of like working their feature modules, improving the experience, and then ensuring like other bits, other metrics, other things are then improved. Like for example, we going from 25 to around 70 modules, kind of help the teams to really focus on their code in isolation, and there they can really optimize that. Then we can kind of benefits from other improvements. Like right now we're even trying dynamic navigation, things like that, or backend driven. So that's what sort of the things we are kind of trying to explore at the moment.
Okay, but I really talking about some concrete metrics.
Metrics. What sort of metrics?
So seconds, milliseconds, for example, minutes.
Oh, okay. You wanna?
Metric for your
Yeah.
time or each time or something.
Sure. Yeah. I like, to be honest, like was very hard to put everything we wanted to put in the talk because of the time. But so like, we.
Nice to hear in the future, for example. Yeah.
Oh yeah, totally. Yeah, we were definitely gonna share that. I know by head that, for example, we monitor our average app launch time, and it's around 800 milliseconds at the moment. In Datadog, we have a monitor, we have SLOs, everything. I really wanted to bring that. We really wanted, but it's super hard to fit everything and make the talk like usable for everyone. So, but yeah, maybe we can talk more later and share other metrics. Definitely, we can talk about that.
Hi, thank you for the talk. You partially answered what I was gonna ask, but I want to hear what's your experience with Xcode stability using SPM? Because I'm working on a project right now that has like 30 external dependencies and like a couple of internal local packages, and every time we change branches where the package resolve is different, Xcode crashes, and we need to relaunch the Xcode. I mean, we need to relaunch Xcode, and it's calculate the whole dependency, and we can't build until it's done. So we need to be looking at Xcode until it's done and then start building. So it takes a lot of from the productivity. You run into these kind of issues?
To be honest, like I think not so frequently. Like from time to time we do, especially when package resolve changes. I guess it's because a version of your dependency changed the version. So we generally kind of ping our dependencies. So we generally use the strategy of up to next minor, for example. And we had one issue, especially for one third party the other day, because it was kind of bumping up automatically by Xcode and generating these issues. And then what we did, we acted on that specific third party. We pinned that out into a specific version. And then whenever we want to bump it, then we actively go there, bump, and then we avoid those sort of issues.
But you do need to, I mean, when you bump, you do need to kind of clean and calculate the dependency again and then build it again, right?
Yeah, I think so. To be honest, I don't remember by head, but I think yeah.
Yeah, because our problem is like when we're working on a branch that has something that was intentionally updated, it's hell to go back to dev to merge stuff, and go back to the branch. We need every time to, so that takes a lot of the productive. But okay, thank you.
Thank you. Yeah, I guess that's why even I don't have much experience to mention.
I think also to mention that when we open Xcode up, it freezes for a few seconds trying to resolve the graph. That's something that's down to Xcode. It's not really, it just does it in the UI thread, I guess, and everything freezes up. But because our Swift package, our package.swift file is pretty big and it's got a lot of stuff to resolve, it takes like 3 seconds and then it's responsive and then you can kind of go. But it's an ugly piece of user experience there on that side, but it's not a huge deal for us, and we've never had, well, I personally haven't had any crashes so far. So yeah, I think.
Thanks for the talk. I have two questions. First would be,
How difficult was it to coordinate it with the whole team to execute on that project? And the second would be, where do you go from here now?
Thank you. So yeah, we had a, as I said, we had an exploration phase when we had the decided or the proposal for the setup. We shared with the team, everyone reviewed it, and then when we decided, we also built like a migration plan. In that plan, I remember we specifically tried to separate what we could do without impacting the team that would be backwards compatible, and really focus on that first. Then we migrated everything to main. We tried to impact the team as little as possible, and then for things that kind of changed a lot the setup, and it couldn't be backwards compatible. Then we just created a feature branch, and we did a one-time switch. We kind of had a freeze period with the team. Everyone was already kind of playing a bit in that branch, and then we switched it. We had some scripts and we faced some issues here and there, but then we coordinated, helped the team, and everyone was just using the new setup and starting to report those sort of like issues or and then improvements, and then we were already trying to experience. And then where we want to go, I think apart from the downsides I mentioned, the ones you brought up as well, and some things we have with SPM, it really brought a lot of benefits for us. So we really want to stick with it. And like I said, our goal for now is we still have legacy code. So at that Xcode project I shared with the main app, we still have legacy code there. Our idea is to keep extracting code to modules. And then we have the dependency injection system there, routing. We want to also have that within SPM. And then ultimately have the Xcode land or projects very lean. So that's what we aim. And we really hope Apple keeps pushing the boundaries with SPM, and we're going to be able to benefit of other improvements. Like they just shipped the SPM plugins and things like that. These are things we are looking forward to benefit more and more.
Cool. I guess one more question if we have one more. Yeah, okay. Go for it.
Again, thank you for the talk. Did you had a chance to look into Spotify's XC remote cache by any chance to improve build times?
Yeah, that's something we have in our North. We look at that. We want to try in the future, but it's something we didn't prioritize that. We really hope that's going to improve on top of what we did. Another thing we're keen to try out is like pre-compiling all the third-party dependencies, because they don't change much, and when they change, we can just change that specific one. We really hope that's going to help us cut down even more the build times of our project.
We also saw that XC remote cache doesn't support Swift Package Manager. That's something that kind of wasn't applicable to us, and that's why we kind of looked more towards pre-compiling third parties and have them hosted on like a AWS public thing and just downloading it. SPM does support hosting pre-compiled binaries.